Whom are we waiting for?
Okay, let's see who we have. Ian's here, Edward, Dhruva, Rylan, Will, Ian is here, Catherine is missing, Ricardo's missing.
And someone else, right?
Everybody else is here.
Everybody else?
Well, we'll start with the review. Hopefully they will join us.
Okay.
Okie doke. So you guys, on yesterday, do you have any questions? No? Then I will have questions for you. Let's go and refresh our memories. So do you guys all see my screen?
Yeah.
Okay. So then you should be able to answer. Which cable will have higher resistivity from the ones on the picture?
A.
A will have higher resistivity?
Yeah, I think so.
It's B.
And somebody thinks this is the thickest one that will have higher resistivity.
B.
So let's refresh what the resistance is, right? Remember
Resistivity is the property
A.
of electric current. So
B.
do we think the thicker cable will resist more or thinner will resist more?
B.
You think the thicker will resist more?
Yes.
Now let's think about the water analogy again. Which hose will resist more for the water flowing through it? Super tiny one or a super thick one?
Super tiny one, I think.
Tiny one will resist more, right? Because you will not be able to squeeze a lot of fluid per unit of time.
Yeah.
And
Wait, so
thick one, you can put a lot of water.
It
So
depends,
less.
Well,
Electricity is very similar to the water in many cases. And that's one.
it depends how fast it's moving, doesn't it?
No.
Like
no,
if
not
You have the
really.
same kind of force with which you stuffing the water into the hose. The thicker the hose, the more water you can put in with the less effort. You can try it yourself at home if you have two different type of hoses. Or you, for example, if you are drinking a smoothie and you have two different straws, one thicker straw and one thinner straw, from which one you're going to suck much harder to get any kind of smoothie into your mouth?
The smaller one.
Smaller one, of course. So smaller ones resist more. So the same thing for electricity. The thinner the cable is, the more resistivity. Exception is the only if we go to superconductors, and then the whole physics changing. But in the real world, if you want to put more current, more electricity through the wire, you need to go with the thicker cables. That's why in Arduino we have those teeny tiny ones. And if you want to connect a pressing iron to your wall, you probably will require a little bit thicker wires. Good. So what is the unit of measurement for current? Yesterday we were covering Ohm's law. Who remembers?
Okay.
Which one?
C.
C?
Yeah.
This is the question that the science fair judges like to ask if you come to the science fair with the any electrical project. So be prepared to answer this one and know the answer to this one. They always ask this question if you come to science fair with the project that involves electricity.
Ohm's law is the basis of the electrical engineering. So that's the first thing you learn.
Watts.
Watts.
Volts. E.
Can you bring the triangle from yesterday? Or it's not here, right?
That's our triangle. Universal solution for any problem connecting with electricity. If you want to know voltage, you take this, multiply by that. If you want to know the current, you take voltage and divide by resistivity. And if you want to do resistivity, you take voltage and you divide by current.
And now I remember the units in which yesterday each of these were measured in. Yeah, so don't write that one, just leave it to them to remember. What was the other one, guys? Remember we had 10 ohms multiplied by 5 what yesterday?
Yeah.
What was 5? What was the measurement unit for 5? Remember the answer was 50 volts yesterday? And how
Yeah.
did we got it? We multiplied 5 by 10. We had
Yeah.
10 ohm resistivity and 5 what? How did the question state the current? What was the unit of measurement for current yesterday? For 5. Take a guess.
This is hard to remember, actually. Anyway,
Yeah, well, you already
correct.
have volts, you already have ohms, so you can exclude those, right?
The only two left is this
Yeah.
guy and this guy.
So which of this is the measurement of current?
No.
Ohms.
Somebody's still saying ohms. Ohms is not in the question anymore. We know that ohm is a
Oh, okay.
resistivity.
Those two are gone. Okay, I thought.
Ohm is a resistivity. Volts are the voltage.
Remember in your package, we have
Oh, volts.
that measures ohms, right? It says ohms in it.
Exactly. Your resistor measured in ohms. So ohms obviously stand for unit of measure for resistivity. So the other two things left is amps and watts, from which one we never touched. We never discussed what watts are. So the only one remaining here is this guy. Yes, amps.
Yeah, we had 5 amps multiplied by 10 ohms yesterday to find the 50 volt answer, remember?
Excellent. Anyway, now you should remember.
Remember that. Yeah, this like Tim participated in science fair all his life, and whenever he went there with the project that involved electricity, that was the first question judges asked at the science fair. That was their measurement of how well you know electricity, so that you're confident that you actually did the project, not your parents, right?
Excellent. All right. Now, once you know what voltage is, how many volts in Arduino's digital write high? How much Arduino puts out when you send her this command?
5, I think.
5 volts. That's correct. Good job. 5 volts. All right. Now, building up on the Ohm's law, which is the correct equation to figure out the voltage?
D. E.
Everybody thinks it's D?
Yep.
All right. You're correct. Excellent. Good short-term memory. Oh, Catherine is here. All right. Now, some other words that we don't know yet. What is the positive terminal of the battery called? A, anode, and B, cathode.
A.
Anode.
Yeah. A.
Hey, how do you know that? But that's correct. Yes, anode. And yeah, in electricity, whenever we talk about positive terminal of any circuit, we're talking about anodes. Yes, that's good. All right. Now, yesterday we were measuring some distance, and for that we used some math. And I have 4 options for you here to choose from. How do you calculate distance to an object using sound echo? I'm assuming bats know math very well, because they rarely crash into things. Or they're programmers.
B.
So you think it's time multiplied by speed of sound and divided by 2.
Yeah, I think so too.
Why there is 2 in there?
I don't know.
Why do you think?
Just a guess.
Makes the most sense from yesterday's
Oh.
code.
Divided by 2 or times 2? The slash is divided by 2. And
Yeah, slash is divided. Yes, slash is divided by 2. So why do I have 2 there?
Because
it
you're
goes to an
dividing
object
the distance
and
between.
it goes back, and that's speed of sound. But we're trying to measure only the time when it goes there. So we have to divide it by 2 because speed of sound is there and back.
Exactly, that's correct. Actually, so the travel, the wave, the sound wave, has to travel to an object and back, and we're not interested in double the distance. We only want to know how far the object is. That's why we divided that too. So, but air has to travel. The sound has to travel from your source to the object and then bounce back in. So it makes it doubles the distance. Very good. All right, electricity is the flow of what? A, electrons, B, protons, C, photons, or D, neutrons?
Electrons?
A.
A. Everybody remembers the school material very well. Good. A, it's electrons. What does IR stand for? We were doing IR yesterday. A, interesting rays, B, infrareds, C, infrareds, or D, infrareds?
Infrared?
Infrared.
Infrared.
D,
What does infrared
infrared.
stand for? What is it? What does infra mean?
Basically, it sends a signal. A remote sends a signal.
You're describing the principle of operation of the remote control. But infrared actually stands for the wavelength. So if you look at the visible light and the spectrum that humans can detect go from ultraviolet to white to red, right? So anything below with a shorter wavelength than white goes into ultraviolet, and everything with a longer wavelengths past the dark red that we cannot really see is infrared. All right, good. Now, can you identify the IR receiver on the picture below?
A.
A.
Are you sure it's not B
A.
or C?
Yeah.
B is the ultrasonic sensor. And then I have no clue what C is.
Yeah, this one is a
Okay.
Hall sensor. It measures electrical fields. So, good job. You discovered your infrared receiver correctly. Good job. All right. Another bonus question: is infrared receiver a digital sensor or analog?
Analog.
Did you connect it to A1 port or to pin numbers? Remember? The digital ports are the
Analog. Analog.
Were we connecting infrared sensor to analog port or to digital port yesterday?
Yeah. Remember on your Arduino you have pins 1 through 13 here on this side, the digital pins.
Digital.
And then we have analog pins on this side, A1, A2, A3, right? So which one did you connect it to?
Digital.
Digital.
That's correct. Infrared sensor sends encoded signal to the
And if you look at your
Arduino.
Arduino board, it actually tells you digital over there.
Oh, it does.
Yeah, and it says analog on this side.
Okay, very good. Good job on that. So today, what we're going to be covering, I already gave you a sneak peek, is we're going to be looking into the motion control. So far, we didn't touch motion. All our interaction was with some blinking lights and some numbers thrown into the serial monitor. We're still going to be using serial monitor because we'll like peeking into the inner workings of Arduino.
Before we start though, does anyone wants to show their homework project?
No.
No, it's a secret. It's a top secret government project.
But did you, can you speak up if you actually made it?
It's gone.
It's gone.
Okay. Anyway, what we're going to be using today for controlling motion study is we're going to be using micro servo. Micro servo is this little blue guy, which is in essence an electrical motor, a lot of gears, and some electronics inside it that will allow you to control it precisely. So most of the motors, when you give power to them, they rotate, and we cannot really tell how many rotations the shaft makes or where exactly it will stop when we cut the power to it. With the servo, you have very precise control. So that's why servos are used in robotics. And we can brainstorm today about different applications that we can use the servo. Servo has, well, I already covered. So the servo that we have in our box can have only rotation space from 0 degree to 180 degree. It doesn't even rotate a full cycle. It only does half rotation, but it can do with a high precision. So you can give it a number, like 30 degrees, for example, and it will move exactly that. So you can design precise machinery around servos. We have 3 wires. Usually they are, in our box, are yellow, red, and brown. So brown and reds are the power, traditionally. It's like in a digital sensor. We're going to provide ground to the brown wire and plus 5 volts to the red wire. And the yellow wire, we will connect it to one of the digital pins of Arduino. And we will be passing instructions to servo through that signal wire. Ian, that's exactly right. That's what it is.
Red and black.
Yeah, you found correctly. All right. So this is the connection that we will be using. So we're going to use potentiometer to encode the position. And servo will be connected to pin number 9. Let me switch over to Tinkercad. We're going to create new circuit because this way I have more control than with the picture in the PowerPoint presentation. So let's bring the our components in.
Incredible. Lippy.
Maybe this way I will put it like this.
Where's Incredible Lippy?
And we will need a servo. Where is our servo? Here, micro servo. And we will need a potentiometer. Where's our potentiometer? Here. Okay, so let's quickly wire things up.
Alex,
Yep.
are we supposed to screw the thing in? Where's Incredible Lippy?
You don't have to screw it. It fits quite snugly. So all you need to do is just put that white thingy that is inside the little plastic bag with servo.
Wait, it's this thingy?
No, this is the stepper. So this
Oh.
servo looks like this. It's a little blue one.
Oh, okay.
Yeah, like that. So yeah, take this white little controller arm and snugly fit it on top of the servo. This way, when it rotates, you can actually visually see the angle to which it rotates.
Can't find your set there.
It's in my set. It was in the second compartment.
No, I got the thing. I just can't find the thing. It's just not.
It's in the same package.
No, I'm
This
not-
one?
I can't find the program thing. It's not
Oh.
turning on it.
Oh,
Am I supposed to get a screwdriver?
It's not turning up for some reason.
No, they didn't include the screwdriver, and we don't really need to screw anything
Okay,
in.
Will, are you talking about the Tinkercad? You can find the Tinkercad? Or,
It's this thing, right?
How'd you get on that?
Yeah, that's correct, Ian.
yeah, this is how it
Then
looks
you
in
need
my
this
package.
weird propeller.
How'd you get on?
Wait, why does your things have these like white things on?
No,
There's also a white things on in the
That's
back
his.
where servo is. Yeah,
Yeah, I know,
you
it
take
has
one of those,
screws,
exactly,
though.
Dhruva.
So
Yeah,
now
take
you
this
can
one,
see how it spins, right?
and you put it on a shaft of servo.
oh,
This way you can see how it spins, because otherwise the shaft is round, it's gonna make some sound, you're not gonna see.
Guys, for those of you who know
This?
Lego, I just brought a motor. So this motor, I'm sorry, yeah,
Oh,
this
yeah.
has exactly that server. If you take this apart, you'll find that server inside of it, okay? And you guys know how to program it using degrees and everything, so that same rule applies.
you're wrecking your motor, aren't you?
I'm not writing the motor, I'm just
It's supposed to look like this, right? When you
want to
put
tell
it
you
in.
that, yeah. That's and people take it apart, and that's the server inside of it.
Do we need to screw it in though?
You don't, no. It snugly fits. Just clip it on. Just clip it on and it will stay firmly on.
Okay.
You can even use it in the same way without screwing in to operate little mechanical parts. if
Do
you
we
want.
need this?
Yes, we will need potentiometer, exactly. We will have to generate some sort of input for the servo, and this way we can use potentiometer to spin it, and it will transform to servo. So let's connect our things together. You should, guys, remember how we used to connect the potentiometer. Let me just plug it in here somewhere. And we're gonna go.
The potentiometer was the one with the knob on it, right?
Yes.
Do we need to empty our board? Do we need to empty our board?
Empty? Yes, I would suggest to do it. If you have some extra room there, you don't have to. But if you like things to be tidy, yes, please.
So that you don't have too many cables. Or
Like I've kept the photo sensor on and the other one that we have done yesterday.
You can keep it if you want.
No. I can rebuild it, probably.
Okay. Yeah. I mean, the more time you rebuild it, the better practice you get in doing it.
Yes. Yes.
Okay. This is signal. This is power. This is ground. So I'm gonna connect ground to the ground. Power. And make it red.
What? Signal, which one's power, which one's ground?
So I'm gonna keep the colors of it the same. So I'm gonna use brown if that exists here. Brown. The red would be for the power, and the yellow.
Okay, Alex, this is the end they have. So how do they know which one's ground, which one's power?
By the color of the wire.
You're using same colors?
I'm gonna use the same colors. Yes.
There is no green. The other one's yellow. Oh, okay.
Yes, it's just by default green. When I pull it, I'm gonna change it.
This part.
There you go. So it's gonna look something like this, guys. Both of them, potentiometer and a servo, requires power. So we're gonna tag them into the into our power bar. So red ones go for the anodes or positive. The brown one or green one goes to the. Do you want to keep everything brown for consistency? Let me do that.
Okay. Oh, the brown.
Where do I put the yellow wire? Which one do I put
Yellow
in?
wire, I put it in the pin number 9.
No,
But
like yellow.
it's not
the
critical.
yellow
So
wire.
in order for compatibility for the program, I suggest you do the same. Put it in pin number 9, and this way, when I share the program, we're gonna have.
No, which one do I put the yellow wire in? Do I put it with the orange one, the red one, or the brown one?
Like this, right?
So the brown one goes on the negative.
Brown goes to the
You have
negative,
like
red
this?
goes
No.
to the positive, and
The
yellow
color
goes to
connects-
pin number 9.
No,
The way Alex did.
do I put the yellow one connecting to the orange one, or do I the yellow one on the sensor?
Oh,
Really?
on
On the
which
sensor,
sensor?
do I connect the yellow one to the orange?
you don't connect it. Well, actually, yes, that's a good question. You see the wires actually have female connections there, so they don't have pins. So you're gonna have to use some other wires. So for example, if I'm to connect it to the ground, I'm gonna take this this pin and I'm gonna put the brown wire into an extension so that I'll have pin on the other end. Then I can actually plug it into the breadboard. So color of the wire that you plug it into it doesn't matter as long as you trace it and the brown color that comes out of the servo ends up connected to the negative. Okay. And the red one connects to the positive.
The yellow one goes all the way to.
And yellow goes all the way to pin number 9, exactly.
Mhm.
Okay, and where is our fancy potentiometer? Here it is.
You want to show us your contraption, Alex?
I could. but I won't.
Uh,
It's too much hassle. I have to like play with the background, remove it, and then bring it back on. Excellent, excellent.
Is this? Oh no, that's no. I'll do it different way.
We were hearing you all the one. No, I wasn't so silent.
Oh my god.
Alex, can you?
Oh,
I
okay,
beat the
never
design
mind.
thingy.
We need a diagram, Alex.
Oh, I'm sorry, I'm sorry.
That was my brother singing.
Shut up.
Yep.
I'm telling you. He's got his speaker on.
So, don't sing.
You don't.
Do we need to stop it?
Turn it off.
Stop it!
Ow!
Guys, please don't fight. We'll love you both equally.
Yeah, Alex, remember potentiometer has leg on the other side. Where would they
Yes,
wire?
yeah, potentiometer, if you guys remember how we connected it last time. So let me try to use the contraption thing here, the Gibajik. Where's my video?
Remove the other sensors. Just leave what you have on diagram, not to confuse anyone.
Okay. So here is the way I connected the potentiometer. The two legs that are on one side, I have connected on the side that is closer to the power. So I could get these wires plus and minus connected to it. And the other end is bridging the gap over on the other half of the breadboard. And that's where I connect my sensor pin that goes into the analog.
So, can you connect it like the wires like you usually do? Like
Yeah,
okay.
for sure. Do you see my
Yeah, can you turn on the light so it's brighter?
it is on.
Oh, it is on?
Yeah.
Okay.
Wait, how'd you connect that wire to there?
Which one?
Onto the top of the heat sensor.
It's behind.
Oh, it's just behind.
Yeah, it's like this.
Yeah.
Because potentiometer has one extra, like one leg on the other side that goes through the gap. So it's not exactly as the diagram shows, right?
So do we need to screw in the
Not screw, just fit it in. Just fit it in.
No,
and
if
keep
you
it-
notice, I don't screw it either. So you just basically put it in and snugly press it hard and it clicks in place.
Oh. And what are the holes for?
Those holes are usually for connecting the linkages to different different mechanisms. So those servos are most frequently used in the steering of remote controlled cars. So if you want to connect this to a steering mechanism of your car, depending on the travel, you can either connect to the hole that is farther out, or if the travel is small, you connect to the hole that's closer into the shaft. That's why there's like a lot of them. And there's a teeny tiny little screw in the back. That screw can go into that hole and you can connect the linkage from here to the thing. So for example, remote control helicopters, remote control cars, robotic toys, they all have some sort of linkages connected to servo, and that allows them to do jobs, either grab things or steer the machine. Or maneuver any part of the mechanism.
Alex, which pin number did you use for the middle output of the Potentiometer?
A0, analog 0.
A0. Okay.
Mike's on. So can we do the programming now?
Yeah, we can go to the programming now.
Why is it half table, half geneotech thingy?
It has what?
It was like half table, half geneotech.
Yeah, it's the background thing. Okay, so everybody have built their circuit, and now let's look at what we're gonna do with it in terms of programming part. I'm going to actually do my traditional thing. I'm gonna go to code in the same sketch, and I'm gonna delete whatever is in there, and I'm gonna replace it with the actual code that we're gonna use. Code is super short and very simple to understand. And I will replace the name of it on Alex Servo. Alex Servo, so you could easily find it. And if you need to borrow the code, you can do it. I also will be posting it to the chat. And then we'll go through line by line and I'll explain you what's happening there with the code.
Where's your the one that we're just doing? The
one that we built, you mean in Tinkercad?
Yes.
It's
Where
called
is it?
Alex Servo. So if you go to the Tinkercad circuits, you should be able to see it. It's one of the recent ones. This one.
Recent?
Yeah. It's called Alex
Click
Servo.
button in your browser, guys, if you don't see it.
I don't see it.
Refresh your browser.
Refresh the page.
Is that the code in the?
Yeah, in the chat is the code, yes. And also we're using the library this way as well. So I would expect your Arduino to have this library already, so you don't have to bother. But just in case, if for any reason it's missing, you're gonna have to install it. Usually Arduino, when you install this environment, Servo is one of the most frequently used output devices. And Servo library is usually part of the installation. So you don't have to expect that it's not there.
Its code should. Your code isn't built right.
It's not built right?
It's not built yet. Is it?
It is.
No, the code is not.
It is?
Yeah, this code that you see in the window right now. Oh, I'm not sharing? I'm sorry. I'm not sharing. I'm talking to you as if I'm sharing the thing with you, and I'm not. This is horrible. Here it is. Here it is. This is the code. This is the circuit, and Alex Servo. It's right here. It's in Tinkercad, one of the recent designs. I was sure I'm sharing it. Anyway, sorry about that. Here is the circuit, and if you click on the code button, it pops up in here, so you can actually borrow the code straight from there and put it into your project. And we will discuss what that code does. The most interesting thing I'm like here is the mapping of the values that we get from analog to the value that
Wait, do you have it in there?
we're gonna send to Servo.
Nothing you saying you're doing a copy little thing?
No.
I'm doing a copy.
Let me know, guys, once you build it and whether it's gonna work right away. Mine worked like a charm.
Mine worked.
Yeah. So when you rotate a knob of the potentiometer, you should have proportional rotation of the servo. Maybe the direction would be different. So depending on the way you connect it. So if you rotate knob into the right, servo goes to the left. If you want to change it, maybe we can actually just swap the plus and minus on the potentiometer.
I got it. Come on.
So here you go. So now if I rotate to the right, servo rotates to the right as well. So if your servo is reversely proportional, you may need to swap the wires on the two legs of the potentiometer. So plus and minus trade places. So now imagine this, guys. If this can be divided into the wireless part of the circuit that is in one city or on planet Earth, and the servo is connected to a robot and it's somewhere on Mars, and you can control it like this remotely. So that's what usually, guys, happens with the remote control toys. So when you have your controller and you want to turn right, you use the joystick and you move the handle a little bit, and the servo responds proportionally and very fast on the remote control.
Why is it just?
Why is mine not working?
Why is it just going back and forth?
If it wiggles, that means that your potentiometer is not properly connected.
Oh.
Look at the potentiometer, because the servo gets its position from the value it reads from potentiometer. If potentiometer is disconnected for any reason, there will be digital noise happening on the pin A0, and that noise can be translated to the position of servo. I can hear someone got it working.
I've got mine working. It's wiggling.
That wasn't working. I was just tilting the thingy side to side, because when I twist it, it like doesn't really move.
How do you get it to work? Mine's not working.
Oh, mine's working.
Okay, who needs help?
Me.
Will. So I'm bringing Tim and you to the breakout room, Will, and Tim will look at your circuit. You're gonna have to get your camera on and point it onto your device.
Okay.
Onto your design. Tim and Will. Okay.
Oh,
Who else needs help? Except Will. Will is going to the breakout room. Who else needs help? Everybody seems to have it working.
What? Yeah.
So do you guys see the proportional response to the... Catherine, say that again.
Can you show the Tinkercad again? I couldn't find my potentiometer.
Here.
And I just found it, so I need a build.
I need help.
Rylan?
Yeah.
Yes. Okay, Ira, do you want to take on Rylan?
Sure.
Okay, so right.
Rylan, I will assign you to room number 2, and Irada will go to room number 2 as well. Irada, you comfortable with it? Looks like she is. Or we will never know. Emily, you sleepy?
I am sleepy. I was grading last night.
Yeah, that's what's called partying these days? Grading?
No, I was grading projects that
You were
students
grading
submitted.
projects. Good for you.
Yeah.
Did everybody succeed?
No, it was very upsetting.
Horrible.
However,
No.
on average, it was much better than the previous set of projects. So, I mean, you win some,
Okay,
you lose some.
guys, when you rotate your nubbin on the potentiometer, does the servo move in the same direction as your potentiometer nub, or
No,
opposite?
opposite.
Opposite. So if you want to correct it, you need to flip the wires that connect to the two legs of potentiometer. Just replace them with each other. You take the pins out and crisscross and put them into each other's spots.
Okay.
And then tell me what the effect is. Just do it quick because your server gonna go crazy for a little bit.
Alex, my little silver part of the wire came out of the black thing.
Silver part of the
Oh,
wire.
like it disconnected?
Yeah,
Yeah.
replace it with a different wire and throw this one
Yeah.
in garbage.
Get rid of
Okay.
it.
Oh my god.
Okay. It's gonna
Ian,
get
did it fix it?
electrocuted.
No,
I'm-
like my
I'm-
potentiometer keeps on coming out. It's never secure in there.
That's really strange because potentiometer has very sturdy legs and they're quite long, so you can plug it in. And mine, I can actually lift the entire breadboard by holding that potentiometer. It's so snug.
Yeah, but mine comes out when I even like touch it. It's so wiggly.
Really? How do you put it into the breadboard?
I push it down as far as I can, but it doesn't want to go that far down.
Yeah, do you put it across the gap in the middle?
Yeah.
So 2 legs on one side and another leg on the other side?
Yeah.
And you say it's not
Alex,
reliably sitting in it?
Yeah.
Well, try to put it in a different row. Maybe that's just some defective sockets there. And look at your the legs of the potentiometer. See if they're not bent or broken, because they quite thick. So they're supposed to go really snug in it.
Alex,
Yeah.
do the 2 pegs on the potentiometer
It doesn't look broken.
like go towards the power bank, or are they on the outside?
Catherine, it really doesn't matter. What matters is that no matter how you plug it in, you just need to connect wires to the correct pins.
Okay.
Right? So if your leg's on the opposite side, then just move your wires in the rows that are those 2 legs are positioned and connect them to power plus and minus. Doesn't matter if they're on closer side or farther side.
Yeah, it keeps on coming out.
Is it normal that if the thing falls out for like too long, the micro servo starts spinning?
Yes, yeah. That's exactly what happens when there is no solid signal on the analog pin. Because what happens in our code? Look in the code. We reading analog pin in here, and then we take in this value and we map it to the servo. So, for example, if analog pin reads 100, we map it to the value between 0 and 180 proportionally. So we basically put 2 rulers together. One ruler, let me just do the annotation here. I take annotation here. So this is the scale that we read from analog. And they have a lot of different values. And it goes from 0 to 1023. 23 little notches, right? Like this. Now servo can rotate from 0 to 180 degrees. So
okay, mine works fine.
Yeah, we put another ruler like this, and this is our servo ruler, and it goes from 0 degrees to 180. Sorry for my writing here skills. So it has notches in different spots because the whole spectrum is divided for 180 degrees. Each one of it is a degree. So when we rotate the knob in here on the potentiometer, this is our potentiometer. If we rotate this guy, we change the input on the A0 pin from 0 to 123. Imagine when we rotated and then we stopped, and that's where we ended up in. This is our spot here. So this little function here that says val map value is mapping it to the spot on the ruler underneath for the servo, and looks it up and says, okay, how many degrees is here? That's how many degrees we're gonna send to servo. So that's how it is. Isn't that fun? Let me actually look up something for you. Did you guys see this kind of machines before?
I love this guy.
Yeah. Did you see that kind of machines before? So this guy is activated by a servo. So every time you click the switch, this thing opens up the thing and switches it back. So it's called a useless box. I don't know who invented it first, but it's like super cool idea. It looks so interesting. You're trying to like fight with it. No, it should be pointing your way. And this is the advanced useless machine with the gazillion of. You will need a little bit more than one servo in there. You see he's doing it in random order and this thing just finds.
I liked how in the last one too, there was an undeterminate amount of time before the thing came out of the box to fix it, as though it was like
Exactly.
contemplating. It was like, should I? I'm gonna do it. It was great. You gotta put little googly eyes on it.
No, put like a little hairy finger with the nail.
Yeah, there you go.
Yeah.
Something ridiculous. All right, guys. So I'm assuming everybody's works. If it doesn't work,
Let's wait for the rest of the crowd to come back.
let's speak up.
Mine doesn't.
Yours
Oh, mine
doesn't?
works. Mine
Because
works.
I didn't put the code in yet.
Okay, so are you putting the code in now?
Yep.
Okay, cool.
You guys want to look through the code and tell me what you think? Code is super simple here. So if you notice in the very beginning, we have include servo.h. Who guess what it is?
Hmm.
So library that with a bit of a set of code for the servo.
It's there is a word for this kind of thing. Yesterday we were installing it. Remember when we had an infrared and we couldn't use it because we were missing something? What was that thing that we were missing? It's the place where people store books and go to borrow books.
I already said it's a library.
Oh
with
yeah,
just a set
Catherine,
of
sorry,
code.
my bad. If you said library, that was correct.
Yeah, I did
just
say
didn't,
it might
I
have
just
just
didn't
not
hear it.
happened.
Yes, it is library. That's correct. So we including servo library, and what is that? What it does? So if, for example, I'm to remove it, and then I'm trying to upload this thing, it's gonna say, oh, all of a sudden Arduino stops understanding my commands. It doesn't know what servo command is for. Okay, because without a library, it doesn't have necessary knowledge. So if I bring my library back, that library contains all the instructions for Arduino to understand the code. So now if I'm saying servo my servo, it means that I am setting up a new servo. For one Arduino, you can connect multiple ones. So for example, if you're building a robotic hand that has 5 fingers, you can connect it to 5 different servos. So you're going to connect servo, my servo 1, my servo 2, my servo 3, and so forth. Or you can call them fingers, finger 1, finger 2, finger 3. And this is how you initialize them. Now, what is the pot pin equals 0? Who can tell me what that means, what that line does? You guys should know by now. What is pot pin equals 0? What is pot short for? Anybody?
The twisty thingy?
Twisty thingy. What it's called?
Sensor thingy.
Okay, it's called potentiometer. And pot pin is the pin that we connect our potentiometer to. So pot pin equals 0 means we're going to use pin 0 to connect potentiometer to. All right, so we're setting up a variable, and next time when we call pot pin, it's going to assume that it is 0. So it's the same thing as if we delete this line entirely, and in this case, in here we put 0. Make the code even shorter. But it's a good practice, actually, to have the variable set up, because it might be used in many spots down the program. And if you decide at some point, I don't want to use pin number 0, I want to use pin number 1 because it's closer, or I don't know, it's busy, it's doing something else. In this case, all you have to do is replace it here one time, and all the other program gets updated. Now, we're setting up another variable, called it val, short for value. That's where we will be putting whatever our potentiometer reads. So whenever we twist the head of potentiometer. Now, in a setup function, we're attaching our servo, and we're attaching it to 9. What does it mean? Was Crancy missing all this time? Hi, Crancy, we were missing you. Where were you?
I was like, I had a little competition, so yeah.
Competition? Did you win?
I don't know.
Oh, what was the competition about? Coding?
No. It was about math and stuff.
Oh, nice. Okay, well, then you have a lot to catch up with. So we were building a circuit where we were using our servo. Servo is a little motor, the blue guy like this. Oops. Why did I mess it up? Put it back. It's a little guy that looks like this. If you go into your box and try to find it, it's called micro servo. Find it. And also you will need to clean up all your breadboard, and we will need potentiometer and the servo. So those two things. You still remember how potentiometer looks, right?
Yeah.
Little thing with a twisty nubbin. So guys,
this one?
Servo, yeah, that's the servo. Guys, those who have it working, you can take like 5-minute break. Go to the washroom, get a drink, or just think of a thing that you want to ask me if you have any questions on what we were covering so far.
That was fun.
Gets you some ideas, right, of what's possible to make with those kind of equipment.
Do we need the LED lights?
We don't need LED lights, no. We just need the servo and potentiometer. Once you found those two things, you're gonna have to connect it like this. Why I can hear Irada even though she's not in the same room? Is it Ryland's computer?
Ryland is out, yes.
Through Will, yeah.
Through Will, yeah. Will is a conducting. Will, did it work for you?
Mm-hmm. Yeah.
Excellent. Is it revolving in the proportion direction? When you turn your thing to the right, servo also moves to the right?
Somewhat. Yeah.
No, there's only two options. It can either go to the opposite direction.
It's a little bit jittery right now. Alex, is yours like smooth? Or
mine is super smooth, yeah.
Yeah.
Okay. Well, I don't know. I checked his wiring a couple times, and there wasn't much I could find.
How about his code?
His code's also exactly the same as yours.
Exactly the same. Is the potentiometer plugged in strongly into the breadboard, or just sits there?
I don't know. He pulled it out and plugged it back in a couple times. I'm not sure how hard he put it in though.
No, mine is like super smooth. I can control Marser over with this thing, and it will go exactly where I want it.
Yeah.
Mm-hmm. Okay, Crancy, did you build a circuit?
Well, I have to push in the potentiometer as I'm doing it, then it works.
Ah, okay. So it's actually the potentiometer not having a reliable connection there. I don't know why it happens actually. Ayan also was complaining, saying that it's not sitting there strongly. My potentiometer sits so snug in there, I can just lift the entire circuit board with it,
What?
and it sits in there.
Okay.
So that might be it. Will, try to plug it in
A
tighter.
different,
Yeah, just press on it as hard as you
It's a
can,
little
and
bit
make sure that
better.
Try not
it's
to
super
break
flat.
it, but yeah.
I'm just gonna try and move it to a different spot on the board.
Yeah, try that too. Yeah, then
Make sure
you're gonna
you
have
put
to
the wires
reposition the
over
wires.
And make sure this time you put the wires in the right rows, though. Okay.
Now it's snug.
Okay. If it's snug, try that.
Still a little jerky.
No,
Move
it's
the
not
wires over.
downloading.
Still a little jerky, but it's following me pretty well.
Okay.
Something, it's starting to wiggle a tiny, tiny bit.
It's jerking, but it's following.
How do we go back?
What are you trying to do? You got it?
Mm-hmm.
What are you trying to do now?
At the very bottom. What?
What's happening right now?
Let's stop sharing. You trying to exit the meeting?
Okay, leave room.
You're not recording, Alex.
I'm supposed to.
You're not recording.
I'm not recording.
No, you're not.
Yeah, he is. You just
He
can't
is
see the word
I am
recording
recording.
very
Yeah,
good.
is this your screen sharing? And there's a little red button there, so we're good.
Okay.
Oh,
what
Iran
do
is back. Is Rylan has been taken care of?
Yeah, he's working.
Everything works. Yeah, we got Crancy who's just joined us. She was
Hey,
at the
Crancy,
she was at the
hi.
competition. Yeah, she's
How was
built.
the competition?
She said she won first place.
Oh, wow. What competition was it?
No, we don't know yet. She just competed, but we don't know the results.
What competition was it? Fancy, you're muted.
It is a math competition.
Math.
A math competition. Wow, good job.
We're impressed.
Yeah.
We're going to use a lot of math in the second half of the class when we'll be converting resistivity to temperature.
Okay,
There's
what
a-
did Darren and I miss?
11 o'clock now, so.
It's 11, so we're going to be switching to the second part of the topic, but I want to make sure that Crancy is taken care of. In the meantime, while you guys were away, Will and Rylan, I was showing the useless machine.
Okay,
And
but I think Will is reminding you about the 5-minute break.
yeah, no. Yeah, if you want to go to the bathroom and go take a drink, for sure. I just want to show you application for the servo. This is a useless. This is one of the most advanced useless machines I've ever seen.
Useless board. Oh my god. It doesn't let you.
It says, don't touch him. Don't touch him. Pretty good, huh? So yeah, once you know how to do servos, you can do that kind of operation, okay?
Did you video that? Like, did you video that?
No, we're good for it.
I want to demonstrate your contraption. The Boston Dynamic dog that you're assembling.
Oh, the
Yeah,
Tims?
let's do these.
Yeah, Tims would be awesome, Tim. When you have a chance, if you can like wire it up and plug it in. Let me find something.
Just to inspire you guys. And Alex, does the Tinkercad have any sketches that they can actually play with? Like the big balls?
I'm pretty sure they do. So this is young Tim when he was little, and his science fair project when he built a robotic hand out of Arduino. So each one of those things on his hand are on a glove is the linear potentiometer. So it's not a nubbin, it's like horizontal.
I have a question.
Yeah.
Do we need screws for these?
Do we need what?
Screws for the servo.
Screws? No, we don't need screws, no. This white thingy that goes on top of it, it just snags on top of it. You just put it on and just you click. Yeah, exactly. You don't need to screw it in.
And then?
Excellent. So now everything's connected, right? So now you just need to borrow the code. You can either go it from Tinkercad or there's a copy of it in the chat. Do you see the chat or you just connected too late and you don't see it?
Can see it.
Can see? Yeah, so copy the code from the top to bottom and replace everything that is in your Arduino right now. Starting from include servo.h.
It doesn't show anything on the chat.
Oh, you don't see anything in the chat? Okay, let me repost it then. I will copy this thing here and I will post it again. Do you see now?
Yeah.
Okay. Okay, and while you guys were away, we were looking through the code, and I was explaining how this mapping function works. Do you see this thing here, this line that is highlighted in yellow? Yes?
Yeah.
So what this does, it's very frequently used in Arduino in electronics design. It's meaning that we're gonna have to align the reading of one sensor to the range of operation of another output device. So for example, if our if our servo can only rotate from 0 to 180 degrees, but our potentiometer can produce values from 0 to 1023, you need to somehow align those two rulers. And that's what I'm annotating here on my screen. So first ruler is the potentiometer scale from 0 to 123, and the second ruler is from 0 to 180. And we force them to be the same length, because otherwise they're like, of course, 0.23 is much farther away than 180. So we force them together, so the potentiometer ruler has much tighter connected notches on it with the different values, and servo ruler has a little bit spreader out notches. So when we rotate one, the slider moves along that ruler, and whatever is the corresponding value on the second ruler being sent to the potentiometer, to the servo. So for example, if we're setting our code in such a way that first ruler 0, 123, second ruler 0 to 180. So whatever value we get on the first ruler going to get proportionally mapped to the second, meaning that, for example, mid-range for first ruler would be 512, something like this, somewhere there. And it will translate to a 90 on the second ruler. Does it make sense?
Yeah.
Okay.
When I press upload, it says like there's an exit status 1.
Check if your port is properly connected. Do you wanna be go to breakout room and Tim will try to troubleshoot?
Yeah, let's do that.
Okay, let's see. Currently assigned to breakout room number 1. That's where Tim is.
Mm-hmm.
Okay, so this is how this mapping function works. That's I find super handy. So for example, tomorrow, if you're using servo that has a wider range, or for some reason 180 degrees is not good for your application, your device only requires from 0 to 90 degrees. You can easily correct it. You can just put here a 90 degrees, 90, push your code, and now in this situation, whenever you rotate your handle, you're only going to have motion from 0 to 90 degrees, but with much higher precision. Okay, try that. Try now replacing this 180 with 90 in your code. Load the code, and then try to twist the knob and see what kind of effect it results in.
Alex.
Yeah.
Basically, I had the code in. I've tried to put it in about 3 times, and each time, first the servo starts acting at its own accord, and then after that, it just stops. And when I like twist the pin, it pretty much does nothing except for act.
Yes, that means that your potentiometer is not properly connected. Your code is correct. Your servo is supposed to jitter. So if I'm to remove the pin, let me demonstrate. I
don't think anything is different when you change it to 90.
It's very different. Your thing doesn't move that much. The servo.
Oh yeah, I see that. Okay.
Mm-hmm. So let me.
Yeah, let me put it back to 180 because I like it more.
Remove the background, Alex.
Yeah, I'm going to.
Mm-hmm.
Okay, so look right now. So if I'm to rotate the thing, the full rotation on the potentiometer only results in 90-degree rotation of the servo. And now, Catherine, if I'm to remove one of the pins, I'm gonna start servo doing this. That's because my analog pin right now getting some digital garbage in it. There is no solid signal, and my servo getting really confused because mapping function right now picks up garbage, maps it to the servo, and servo has some unpredictable, crazy movements like this.
It looks like Jello.
Yeah, exactly. So as soon as I plug my wire back, my servo stabilizes, and now it responds back to my potentiometer. Okay, so if your servo always doing this kind of jittery thing, that means that one of the wires is not on its place, or they're not firmly plugged in, or they plugged into the wrong pin. So the pin's supposed to go into the analog 0 like this, and this pin goes to the middle leg of potentiometer, and your potentiometer 2 legs need to connect to negative and positive. Okay.
Mommy, look.
Excellent. Nancy, your works? Terrific.
No, it still goes crazy.
Okay, Catherine, you want to go to breakout room with Tim also? Yeah.
I can get you and Arada into breakout room number 2.
Tim is back, Alex.
Okay.
Okay.
Catherine, move to breakout room number 1.
He's really good at troubleshooting.
Tim is amazing. Yes, Tim, can you jump into the room number 1 and see if Catherine's circuit is properly assembled? Okay, and now we're going to go to the second part of our ballet. Where is my camera? Display eyesight. This is crazy, this thing.
Hey.
Hey. That's my twin brother. Hello.
Did you just have it recorded?
Okay.
That was my first April full day prank. Oh, here's a gun.
I just recorded the video and now putting it on the background. Yeah, try to do that.
It's okay. I'll teach you next time how to do it.
Record a video with yourself doing something and just play it on any meeting. It's like, oh, well, there are 2 of you.
Yeah.
That's funny. Okay, so it is 11:10.
Yeah, I'll correct back my servo to 180 and save it like this. And I suggest you guys do the same. And second part is we will be measuring something else that we didn't touch yet. We already touched the
I'm gonna
light.
leave and rejoin. My internet connection's unstable.
Is not okay. I'm sorry. You hear us okay now?
Yeah, now I can hear you. Okay, before you guys were lagging out a lot.
Okay. All right. I'll try to be speaking slowly. Annotate, clear everything.
Alex, you promised us that we're going to use the propeller today?
Propeller.
Yeah.
Of course, we will use propeller. If I promised, we're going to use the propeller. Okay. I'm going to keep that thing for everybody to enjoy. And in the meantime, we're going to get the propeller that Irada has brought our attention to. And there's a DC motor in there that can drive it.
Alex's propeller. Alex has got the propeller running.
You got it running already?
Yep.
Did you just plug into the power?
Yep.
Okay, but this is not as much fun as when it automatically goes on when we need it to, based on the temperature in the room. So as soon as it gets hot. Guys, by the way, in the propeller, I recommend there's a 2 knobs of the hot glue on it holding the wires. If that get disconnected for you, use some electrical tape or something to connect it together, because as soon as that wire is on its own, it will break off very easy from this soldered connections.
Okay, which wires are you talking about?
On the motor.
Oh, you said on propeller.
Yeah, propeller doesn't have wires. Propeller is the silly thing, silly goose.
Are we using the step motor?
Wait, this motor?
No, we're using
is
DC
this the
motor. DC motor. I am, because of your background, I don't see what you're showing.
Oh, okay. Let me change
the DC
that.
motor?
Oops.
It's the one with the orange top. It's
right, guys. It's this one.
Oh, so it's not this one?
Guys, it's this
Yeah,
one.
like I did once.
This
It's
guy.
not this one.
See the package? This is how the package is.
Alex,
Yeah.
if you plug it into
It's this one, right?
if you plug it in, if you plug it into V5, will it like burn out?
Oh yeah, it will. No, it will go right on and will start to.
No, will it burn out? If you go to V5?
It's not going to burn. It's designed to operate in this voltage level. So.
Oh, okay, good.
And we have also this really nice Carlson propeller that we're gonna plug into the DC motor. And let me see if I have actually a Tinkercad element like this. I'm sure there is a DC motor.
Okay.
So I'm going to use a temperature. Here is sensing, temperature sensing. And we are going to look for it. Here's the DC motor here. It has some weird gears. There you go. That's the one.
Yeah, look at that. It's pretty cool.
What? Spinny thingy? Yeah, exactly. So on a hot day now, you can get yourself some air circulation.
And it doesn't matter which one goes to plus, which one goes to minus.
It spins the wrong way.
Then you change the wires. So,
yeah, change the plus and minus.
Mine works.
Yep, that.
Oh,
Excellent.
it's pretty fast.
Excellent, excellent, excellent. Okay, now temperature sensor. Where do they hide it? Maybe it's in advanced components here. Thermistor. Temperature sensor. Oh, they don't have actually thermistor in here. There's a vibration motor. Wow.
Thermistor is the tool-like thing. This is the.
Okay, I'm gonna have to be showing it then on my.
Is it the
camera.
one in this package, Alex?
On my camera, yes. Yeah, it is on one on the package. So I'm going to disconnect server right for
Guys,
now.
remember where we took the photo That's a photoresistor from? Yeah, with the snake head, it's in the same package. Yeah. In the same package. And thermistor looks like photoresistor, but it's smaller and it has the black head.
What?
Alex, this is the one, right?
Yeah, I'm gonna show it right now.
This is the one.
Still have the silver motor.
Photo sensor? Temperature sensor. So it's the photo sensor? Or is it
Okay, the thermistor is like a really weird little black-looking nubbin like this.
Where do you find it?
This guy. It's in the same plastic bag that looks like this, where all the different elements, the same bag that we were fetching our photoresistor out of yesterday.
This one?
Can you show? Yeah, exactly. It's like a little blob of ink connected to 2 wires. In reality, what's in there is a little piece of semiconductor, and that piece of semiconductor changes its resistivity based on the ambient temperature, which is pretty cool if you think about it.
When can we use the buttons?
Yeah.
I'm afraid not, but buttons are really simple, and I don't know if we're going to have time during this course to do it, but I thought if you choose between buttons and active things like thermistors or photoresistors, those are definitely way more fun than having buttons.
If we have time, you can show how to just...
Yeah, buttons is only basically they have 2 states, on and off, and that's it. Thermistor have variable states. Okay, let's try to connect it now.
Alex,
So
where do you find the thermistor?
in the plastic bag with the small
in
sensors.
the bag where the photoresistor was.
Yeah.
Remember the
Look for the bag with the black buttons, and it also has photoresistors and diodes in it.
I'm confused.
And it looks like
What is it? So I got the bag, but which one is it?
It's this guy. Look at my camera, guys. That's the one.
Black pin?
So how do we connect it?
Okay, we connected the same way as we were doing with photoresistor. So we'll need a bridge. We'll need one 10K resistor like this. 10K.
10K.
10K looks like that. So if you look at the strip, it should say 10K on it. So we'll just need 2 of these guys. So one guy connects to the positive, like this. And the resistor goes to negative, and it's going to hold hands with the thermistor.
Is it 10K, 10K?
10K, yeah, like this.
It says 10K, 10K on mine.
Yeah, exactly. It says 10K, 10K on mine.
I'm gonna go 10K.
So if you notice, guys, but the thermistor connects to the red line, to the red bus for positive here with one leg. Another leg goes into row 50 in my case, but in your case, it can be anything else. The resistor on the other side connects to the negative bus on one side, and it's holding hands with the thermistor in the middle. That's the spot we're going to be sensing.
Where? So do they like go right beside each other?
Yeah, so basically one leg of each is supposed to be in the same row. And we need electrical connection between them. And that's where I'm going to plug my sensing wire in the same row where they're holding hands. And I'm going to plug it in A0 on my Arduino. Like this.
Do you have to put the fan before or after it?
Doesn't matter. You can put fan before or after. So, and for the fan, what I'm going to do is I'm going to put negative in the negative bus and the positive one.
Pin 10?
Sure, why not? Let's do pin 10.
Oh, then where do you plug that orange wire in?
The orange one that's sensing things?
Yes.
I put it to analog 0, A0, right here.
Okay.
I'm confused.
So which way will the propeller spin now?
Well, we will try to see if it's going to spin in the correct direction. If it's not going to be correct direction, we'll just replace black and red wire. They will swap places, and we will fix
Alex.
the rotation this way. Yeah?
I can't find my thermistor. It's under my kit.
It got to be inside. Did you look in that plastic bag? This plastic bag?
It's not in there.
Were you emptying the plastic bag before on your desk, and then might have taken and put not everything?
It is there. I see it there. It's just behind the.
No, this is my bag.
Well, this is your bag. Okay. And I just can show it now?
Oh yeah, I was on the wrong bag. Sorry.
Yeah.
I was looking at the wrong bag.
It's the bag with photoresistors. With the.
Yeah, I see it. I found the right bag.
Yeah.
Happens.
Okay, so.
Sorry about that.
Let's do the coding.
No, I'm not ready.
Let's give another like couple minutes for everybody to be on the same page, and then once it's done, then we will.
Alex, your board is different, right? Because we have minus on the.
I'm confused.
My board is different.
Yeah, our minus and plus are inverted. Is
What
your
do you
board? Are you using the old board from the old Arduino?
Probably. Yeah, this one I didn't open. I used a different one, but it doesn't matter.
Need some help.
It's just plus and minus inverted there. I just want to make sure nobody gets confused about that.
Okay. Maybe in this case, I'll better share the screen and use the Tinkercad instead.
No, maybe just use the other board.
Yes. I need to see the wiring.
Here. It's right here.
Okay, so I'll do the same thing here as we usually do.
I'm really behind.
Yeah, it's okay. He's starting diagram again.
So ground to negative, our same principle that we use everywhere. Plus goes to positive, like that, right? So I'll use a resistor here, and I will rotate it like that.
Oh, that's what I did.
Can I do it at a corner like this? No,
Okay, that's
I can't.
what I did wrong.
Okay, I'm gonna have to have it done like this. And now instead of thermistor, I'm gonna pick something else. I'm gonna use photoresistor, why not?
As you're spinning.
Yeah. This is supposed to be on there. No. This is supposed to be
Like that. And I will connect this guy to here.
Which is supposed to be pin 10. The red one is.
There you go. Now for the wiring of the motor, super easy. We take one and we connect to the ground, and the other one we connect to pin number 10. Doesn't matter which one goes where, it's gonna still spin. If you decide that it needs to spin in opposite direction, we will just trade places.
Kill the microphone.
Can you do that?
Okay, now for the sensing wire, we're gonna connect from here and we're gonna go to A0. Yellow. There you go. So please note, guys, that this wire is in the same row when your thermistor and your resistor holding hands. Okay, so this
Is resistor 10K?
a resistor, yes, resistor is 10K.
And which digital pin are you using, Alex?
Hmm?
Which digital pin are we using?
For the motor 10.
Oh, and for the thermistor.
Thermistor is an analog device, guys. So we're gonna use analog 0, A0.
We don't have two AO pins.
You don't have two of what?
AO pins.
AO?
Like the yellow
A0
wire.
is the analog.
A0. Sorry,
Yeah.
A0, not AO.
Yeah. So what do you mean you don't have it?
You just need one. You don't need to have more.
Yeah, I know, but like then I need to unplug my
unplug it.
micro
Yeah.
servo.
Yeah, unplug it.
Oh, okay.
We're done with the micro.
This is very condensed course, guys. Usually we cover only one subject per day in our fall or spring classes. And we spend a lot of time on different variations of a design, trying to build different logic in it. This time we have only 5 days. That's why we need to cover most of the most important sensors. By now, most of you should have the circuit built.
Yeah, mine's almost built.
Mine's not built because I have a piece of wire stuck in my breadboard.
Breadboard is big, so just ignore that spot if you cannot pull it out.
And guys, Alex is using photoresistor on his sketch, but you guys are using the thermistor, right? That we just found.
Yeah, the black little guy.
Wait, what are we using again?
The thermistor.
You see this little guy here?
Sorry, my screen's lagging a lot. I didn't get what you said.
Do you see my camera?
Yeah, I see your camera.
That's the one that I'm pointing with a pencil right now. Looks like a little blob of paint on 2 wires.
I am just the thermistor that we found with the black head, right? So it's just because, because his Tinkercad doesn't have a thermistor. He's using photoresistor just to show you.
Oh, on your thing, okay.
Yeah.
Yeah. Also, guys, there are a variety of thermistors there in the world. They all designed for different temperature ranges. This one is most kind of handy one because it's our ambient temperature thermistor. So you can measure your own temperature if you want. So you can make electronic thermometer that you can register your own body temperature. It also can measure the room ambient temperature. There are also thermistors, like for example, 3D printers have them on the hot ends that can go all the way up to 200, 300 Celsius. They all have a different design, but principle is exactly the same. There's a semiconductor inside that changes its properties based on the ambient temperature.
Is it this one?
And can I see the head of it?
No. It's the one that like 2 wires coming in.
Is one wire longer than the other?
No.
No, do you remember how the photoresistor looks with the snake head?
Yeah.
So this one is in the same bag. It looks exactly, it looks kind of the same, but with black head.
Black head.
And it's kind
of
smaller.
this is a photoresistor box.
Yeah, it is from the resistor box, but
okay.
I see those two, the one that you show, but the one we need, it's kind of letter A shaped without the middle.
Oh, I think I found it.
Yeah, look. You can also look on the paper insert on your Arduino box.
Is this one, right?
And it has.
Yeah, that's the one. Yeah, that's the one you found it.
Yeah. It's on the bottom row in the middle on that insert in the box.
Yeah, guys, and remember always to use the chart, right? Because you just find the thermistor on it, and it's the last row in the middle.
Can you show the design, please?
Right, so that's how it's the best, easiest way to find it, if you know the name of the element.
I found two motors in my kit. Which one do I use?
The one with the orange butt.
The one that matches the propeller. And guys, you can see Alex's contraption, right? He has it.
It just doesn't work.
You need code.
We haven't coded. We haven't coded yet, right?
That makes sense.
We haven't put the logic for it to work yet.
Is this right?
Clancy, did you try to say something? You're muted.
Is this right?
Can we see?
1 sec.
Okay, I think I got it done.
Okay, now guys, on the coding side here, I will post the code as well as we do it for the.
It was hard to see, Clancy, but we'll see. Once we push the code, if it doesn't work, we'll troubleshoot, okay?
When you guys think about temperature, which degrees you usually think in Celsius or in Fahrenheit?
Celsius.
Celsius, yeah. Me too. If somebody tells me if 90 degree Fahrenheit hot, I don't know, I have no idea.
It's like, that's a little, like, room temperature is about 70 or 75 degrees Fahrenheit.
There you go. It doesn't tell me anything. I like my temperature at 22 degrees C. Okay, code is posted on the Tinkercad, and another copy will go to chat right now. Inside the code, there are some coefficients there, so please don't get confused. Just accept it. I'm not going to spending too much time explaining what coefficients do, but those coefficients are in there to convert from the resistivity of semiconductor because it's not linear properties. That's why we're getting all kind of weird numbers inside the formula. So first thing first is we checking the analog pin. Then we converting it. We're using the coefficients to convert it in the temperature in Kelvin. Kelvin is another unit of measure. And most of the scientific studies in lab in physics are done in Kelvin. So the astrophysicist using
0 degrees in Kelvin is negative 365 degrees in Celsius.
Good for you. Good to know. Perfect. So, and now we have two conversions here. We have temperature in C and temperature in Fahrenheit. And we will be outputting only temperature in Celsius. But if you would like, you always can replace this value here with the temperature in Fahrenheit or temperature in Kelvin.
Oh my God, really? That's so cool.
And see how it's going to work.
I click serial monitor and it's measuring the temperature.
Excellent. Now try to touch it with your fingers. Try to touch that black.
Yeah, I know exactly what I'm doing.
And see.
It's negative 48 degrees.
That's
that
incorrect.
Doesn't seem right.
No. Let me see if mine works better. If I start mine is showing 26 Celsius, which is correct, being under the light. And if I touch it with my finger,
I mean,
it's going to start increasing, and it reads now my temperature, which is 33. And because, of course, fingers are colder than the rest of the body, so I'm showing like 33 Celsius.
Okay, this is not right.
If I lick it with my tongue, probably
Celsius.
It's going to show it better.
I mean, it is kind of cold, but like, I don't think it's negative 48 degrees Celsius.
Yeah, I'm suspecting that you might use different resistors. So try to use the 10K resistor.
I'm at 17.
17, it's a little bit colder than I would expect to be in a room, but who knows? Maybe your window.
No, that's my finger. My fingers are 17.
Fingers are 17. Okay, that's not correct.
Alex, why is yours so warm?
Mine, I don't know. Maybe it's sitting to the warm CPU. And it's under the light. I have the light.
No, the body temperature is 36, so it has to be close to 36, right?
Yeah.
Unless you were, I don't know, having a cold drink.
So the bad readings can be either variation in the quality of the sensor. it might be the thing that you guys didn't use correct resistor, because the correctness of the readings hinges on the proportionality of shoulders of the voltage divider. So this schematic that we have built in Tinkercad, it's called voltage divider because one leg is of resistor connects to the negative, the element that changes its property is connected to positive, and it creates kind of bridge. So let me annotate.
What the?
So if I'm to illustrate it, so I have one resistor here, then I have my variable device that changes its properties with the changing conditions. And in here is where we're reading the output. So this thing is negative, this one is positive, and current is constantly flowing through this circuit. And in this point, it changes with the way that the properties of that thing's changing. So if this resistor is of incorrect value, then we're skewing the reading of the entire voltage divider to one side. So that's why it is recommended to use a proper resistor. So if you guys using 100 ohm resistor, your reading is going to be out of whack. If you're using a 100 kilo ohm resistor rather than 10K, you're going to have a 10 times different. You can still calibrate it using math inside the code.
It won't let me use the serial monitor because it's not on the. It just won't let me use the right COM.
Alex?
Yeah.
So I changed, like, at the back of the thing, I changed the wire to the other side, and now it jumped all the way to 327 degrees Celsius.
Yeah, it happens. Well, as long as it reacts to your touch. So if
I'm not, Dad, I need help.
If I'm touching this thing, I get reaction. So
put Will and Tim in different breakout rooms. We have only 20 minutes left.
Yeah, mine reacts to my touch.
Troubleshoot everyone.
Yeah. So it's supposed to be reacting to your touch. Every time you touch it, you should get a higher temperature. And the same way as we did, guys, with the photoresistor, we have to decide what is the value that we're going to be turning our fan on. So currently I'm reading like 27 degrees. And when I'm touching it with my hand, it goes to over 30 degrees, over 31 degrees.
Mine is in the 27 and 30 area.
Maybe my thing is not plugged in right.
That's very good.
Now it's 29.
Okay, Alice, we have to efficient here. So guys, whose serial monitor responds to the temperature change when you touch with the finger? Ruva is okay?
Oh, mine just goes
Ian, are you okay there?
Grant is good, right?
What's the normal temperature supposed to be?
The room temperature around 20-25.
In 20s, yeah. And then when you touch it with your finger, because your body temperature is higher.
Oh, mine's 26.
Yeah, that's
But your body temperature
mine is also
like
26 right now. So you're reading exactly what I'm reading here.
Okay, and those who have issues, we can send you to the breakout room with Tim so he can actually troubleshoot you.
Yeah.
So who needs to
I have issues.
So who needs to go?
Will needs to go. Well, Ian needs to go. Yeah.
Yep.
Okay, Will and Tim go over to breakout room.
I can take Ian. Yeah.
You can take Ayan? Okay, I will put Ayan in a breakout room number 2.
Okay.
And you can jump there too with him. And in the meantime, I will put a little code to turn the motor on if the temperature exceeds certain value. And for me, this value would be around 31. So I'm going to put if statement here.
Alex, sorry, how do I go to that room?
You select breakout rooms and just join because I have you're in there already.
Oh, breakout rooms and join. Okay.
Okay, so if temperature C.
I got down to 15.
Oh, it's really chilly.
No, my fingers.
If temperature C, oh, if your temperature is going down when you touch it, that means that your legs are not connected correctly. So your thermistor is supposed to be on a positive bus, not negative. So if your thermistor goes the other way around, that means that you're in a negative bus and your resistor on positive. Flip it the other way around. Change the leg going, or change those two wires here.
There we go. Let's see if it works.
Okay, so if temperature above 31, we are going to...
When does it turn on?
Digital right. And we connected our motor to pin number 10. I'm gonna do it high. There you go. And else, we are going to do digital right low.
Oh, mine went up to 32.
Okay, and we also need to put pin mode.
Serial monitor. Monitor the serial monitor.
Okay, let me see if that's gonna work. So right now it's 27, I'm touching it. If it go to 31, my motor starts spinning. Ah! And if I remove my hand, it goes below 31 and my motor stops. Terrific. Brilliant.
Temp C.
Let's try it again. Holding it, 31, my motor goes on.
Enter. If
And you're right, actually. For it to blow on you, you need to put red one to negative and black one to pin 10. Otherwise, it blows away from you. It blows on your hand.
Yep.
And it's inconvenient. Like you need to like somehow secure it because if it just lays on the floor, it's not quite nice. So I need to like make some sort of support for it.
Okay, we can hold it in our hands.
Yeah. So I have added if statement in the code that marks the temperature at which we want the fan start rotating. My temperature is 31. So if I'm to go and touch with my hand, my temperature climbs to 31 and motor starts spinning. And then if I remove temperature, it slowly drops below 31 and motor stops.
So cool.
Yeah.
Did you share the code, Alex?
Yeah, for sure. I'm going to put it in the chat for everyone again.
Oh, okay.
And again, guys, if you want to understand more about coding, we have a separate coding class where we teach the entire logic using the user-friendly Python language, right? So it will actually, those of you who's been to any coding class should have no problem understanding Arduino coding.
It should be A0.
Where do you put the temperature?
What do you mean?
Like, where do you put the temperature you want to put it on at?
Still don't understand.
Did you copy paste the code?
Yeah, I did.
Yeah.
Now where do you...
Now just put your finger on.
Oh, you mean the threshold temperature, right? So I put in these brackets here in the if statement. My middle temperature where I'm touching it, it goes beyond 31, so I put 31 as the threshold. So whenever it goes past that, turn on. By the way, computer fans work the same way. There's a
Oh, mine
thermistor attached to your CPU cooler. So whenever you start playing computer games, your CPU gets really hot, and the thermistor tells the circuit that, oh, your processor is getting a little bit overloaded, and processor turns on the cooling fans in your computer.
Okay, mine works.
Laptops and iPads work the same way.
Mine works too.
Mine works.
Terrific.
Bob, look at this.
Yay.
Mine works.
Look, so if you put your finger on.
Wonderful, wonderful.
You guys are really pro. Look at that.
Crancy, you're good? Everything works for you too?
You're frustrated on the
It's not
first day.
working.
You're all pro.
Crancy says it's not working. Somebody want to help Crancy?
Yeah, you can send us team because already traveled.
Crancy, jump over to room number 1.
Yeah, join the breakout room, Crancy, and I'll be there.
Yeah, Tim will look at your circuit.
Mine EIO work.
I need some help.
Catherine, your works?
Yep.
Excellent.
I need help.
Oh,
Yeah,
even
mine
Irada's works too.
Yeah. It takes a second to actually read the temperature.
Yeah, because temperature has a little bit of inertia. It's not like light when it's on or off instantaneously. Temperature, you need to allow some time for it to cool down when you stop touching it. Catherine, you said yours is not, or yours it works?
Catherine, did you say you're fine?
Yeah, mine works.
Okay.
Nice,
In
good
the
job.
chat, oh, that was Crancy, sorry.
Mine's not working.
Okay, is that Will?
No, that's Rylan.
That's Rylan? Okay, I can help.
Okay, Rylan, you're still part of the room number 2. You can go to breakout room and just connect there. And Irada, also, you're also part of room number 2. Please go ahead.
You know how to go there, Rylan? You see breakout room down where the chat is, where the chat icon is. Just select breakout room and join it. Will yours work, I'm assuming, right?
Yep.
Nice, good job. Okay.
Okay, Rylan is there. You can go.
Wait.
We are back.
Okay, Crancy, all good? Excellent. All right, this is terrific. Okay, guys, now we will need, we have only 10 minutes left, and we would like to wrap up, answer any questions, any feedback from you that you feel that we should have covered, and maybe in this next 10 minutes we can help to understand something that you missed. So let us know. So far, what we have covered, we looked at the variable inputs. We used temperature sensors. We used photo sensor. We learned how to use digital sensors like sonic and infrared receivers.
What?
We learned how to control motors today with the precision and just the simple motors. Do you notice that the fan, you cannot really tell the fan to turn half rotation and then stop, because this is different kind of motor. It can only have on and off. You can also control the variable speed with which the motor rotates. Actually, let me try to see if I can.
I can't figure out how to get.
William, you said something?
No, it's Rye.
Okay.
On his breakout room.
Okay. Yeah, I'm just catching up his voice there. Yeah. So if you guys would want to consolidate, like set more than one project into one program, you should remember how we've done it with the LEDs. We have kept the main setup function and the loop function in the main page, and then we transferred over the the temperature over to the next tab. Let's try to do it here. So this is the temperature program that we have just wrote. And I would like to actually keep it as the separate function. So let's try to create new tab. And I'm going to call it temp. And I'm going to copy the contents of the void loop into the into that separate function. And I'm going to call it void temp and paste everything in here. And now I will just call my temperature from the main program. Let's see if it works. So done uploading. If I run my serial monitor, I got my temperature readings fine. Now if I want to touch my thermistor and see if temperature goes up, my motor starts spinning. And I stop touching it, and temperature stabilizes, goes below 31, motor stops. And now we have very super tidy code. So we can just read the temperature, and our temperature sits in a separate tab, and it's much easier to manage. So you can actually bundle all the project that we've done so far into the single project with the different functionalities in the different tabs. Make sure though, because certain projects that we've done, so let me see what else do we have here. I have, for example, the servo. So if we to bundle servo and temperature in one project, you're gonna have to bring missing pieces to it. So for example, servo has library attached to it. The temperature program doesn't have any libraries attached to it. If you want to bring servo program into this project, you're going to have to bring missing parts. So you need to bring those. Include servo, my servo, make sure there are no conflicts in pin assignments. For example, if we are using potentiometer pin for servo, and we're also using potentiometer pin for the temperature, because you see this, we have temp pin 0 and pot pin 0 on our potentiometer. You're going to have to reallocate them to different pins so that there will be no conflict. Okay? Because otherwise your project is going to be addressing same pins for different applications, and that might cause some problems and conflicts. What else? Yeah, usually this approach is useful when you're trying to build very complex things that do many things, like smart home, for example, smart home controller. When you have to monitor the temperature inside the house, the alarm system inside the house, you're trying to monitor motion sensors, the door sensors, window sensors, things like that. So for that, it's always convenient to put all those things in individual functions, and this way it will be easy to troubleshoot. There's, of course, a lot of advanced concepts that we didn't have time to cover during this camp. And if you're interested, you can write us a quick note saying we would like to learn further, and we'll see if we can introduce advanced Arduino class for our fall season. And there are so many good things that we can build that we just didn't have time to cover. Like software interrupts, the individual addressable LEDs, the wireless technology, the passing information from computer to Arduino and back. Because right now what we were doing, we're using serial monitor just to read from Arduino, but you can actually send information from monitor back to Arduino and do it and make it do some smart actions there. So all those things are still up for grabs. You of course can self-study too. You just look up the different projects online. Go on YouTube. Go to Tinker Spaces, and see if you can replicate some of the cool projects people build. And of course, your kit is equipped with a lot of different sensors. But if you want expansion, Amazon has a lot of selection of different sensors that you can get really cheap delivered to your home. You can get additional parts that if you, for example, want to build a robot and one servo just doesn't cut it, it's not enough. You want to have 3, 4, 5, 10 servos. You, of course, can build individual servos in the pack on Amazon, and it will deliver, and you can take on more complex projects using the controller. Any other questions, guys?
Nope.
Nope.
No? Did you have fun this week?
Yes.
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 Glad to hear that it was good.
Yes.
And guys, of course, some of you are in our different camps. If you have any kind of questions down the road and you want to rebuild any of the project that we've done and you have problems, feel free to reach out. You know where to find us. You can go to the website. There's a chat functionality on the website, or you can just send us a note on our email. We'll be happy to help.
Just saying, I most likely won't actually go on Amazon to get more things because Dad said he has like 10 million robots and
yeah, that's what I heard. That's what I heard. When I passed your kit to your dad, he said that you have a lot of Arduinos laying around the house. So you are all set. You can go and do all.
And then my sister, she also loves robotics. As I said, she's finishing up her last semester in Waterloo. So we also have a bit of motors from her that she left behind.
Yeah, I remember she was doing, I think I was judging the science fair a few years back, and your sister was doing the laser microphone that she could detect sounds at long distance. Was that correct?
I have no clue. I do not know any of her science fair projects. You can ask Mom and Dad, though.
Well, next time you speak to her, ask her about her science fair project. It was quite interesting. It was like a spy technology that you can point a laser to a thing that is 100 meters away, and by vibration of that thing, you can deduce the sound that happens around it. That was pretty cool.
I will, definitely.
Irada, you want to have any last word? I was just telling kids that what else they can do with their kids, and the potential for advanced Arduino class if they're interested to study it further. Yeah, we have so many things that we still didn't cover.
Rylan, your camera is on. Do you want to switch it off? Yeah.
My camera?
No, Rylan. Yeah.
Rylan? Okay,
do we keep these kits?
Yes, you get to keep these kits, guys. They're yours. And we just scratched the surface, right? You can see like how many cool stuff are there. So very, very highly encourage you to actually go and look up the stuff on your own. And Alex, yes, for those like Rylan was with me in the room, can you just quickly repeat where the sources are, where to go?
Sorry, for the courses?
Yeah, not for the courses, just how they can go from here to actually not forget this stuff.
Oh yeah, I was encouraging everybody to look at the tutorials online and look at the different projects people build and to try to repeat it. If you need expansion, any kits that are any missing sensors, for example, if you build a robot and you need additional servos, Amazon has a very affordable selection of different sensors and output devices for Arduino. They're all compatible.
It's a very powerful tool you guys have now, right? So especially those of you who are actually interested in becoming an engineer, like try to find more information, trying to find more projects and actually do them. Just to maybe give you a little more motivation, I want to tell you that the big universities, when they accept you for engineering, they actually want to see your maker's profile. So if you have a maker's profile and if you show, and I've seen a lot of other people's maker's profiles, some people did like, I don't know, some security systems to let people in that goes hand in hand in coding. Obviously, you're a little younger for that, but as you move on to high school, that's the opportunity you're actually maybe working towards.
Actually, guys, the sooner you start, the better, because when you have already in the high school and you have 1 year before application to university, it's too late to build your maker's profile.
Yeah.
You start building it as soon as possible and try to apply for science fairs. Hopefully next year we'll have a little bit more relaxed than this. This year science fair been canceled because of the pandemic. So for next year, ask your science teacher at school if your school has booked any spots on the Calgary citywide science fair. If they not, ask them if you can book it. If they wouldn't want to do it for you, you can always go as independent. And citywide event is huge, a lot of sponsorships, and you can
and
get.
there are virtual science fairs as well, right?
Yeah,
So
exactly. Virtuals is also good an opportunity to participate. So
like
please look
Google,
into that.
I know for sure has the virtual science fair, right? And there are actual cool prizes, right? I remember when Emily was participating, she was actually getting like a couple $1,000 prizes from there. So it's pretty great thing to do. And Arduino actually gives you a lot of like broadens your opportunity and possibility to actually come up with engineering projects over there, right? Okay. Awesome. So that was actually a very great short course. Though usually our course is 12 classes, but this one was 5. But I think Alex, you did a great job covering almost most of it. Let's say it that way. Okay. And yeah, and this propeller was a nice addition in this kit. We never had it before, so this is pretty cool. Okay. Any last minute questions, guys?
I think Tim wanted to show the doggos to the.
Oh yeah,
To
yeah.
the class. So I'll stop sharing the screen. Tim, go ahead. See if you can connect.
What do you mean connect?
No, just give the power and disconnect your background.
No, maybe bring it here, Tim. Bring it here.
Bring it to where? Hold up.
Yeah. Because we won't see it there. Just bring it here.
It's okay. It's okay. It's he needs to get the background off, and it will be.
Yeah, but
the AI gets confused.
I don't know if he wants to turn off his background, but Tim,
Yeah.
you want to bring it downstairs? Yeah, Alex, you can stop recording probably.